So here we're going to convert a written expression into an algebraic expression by watching the video note taker, memorizing words or phrases that stand for operations in math, and practicing for mastery. So in real life, in the sciences like engineering, the medical field, in computer science, many times we're given written or verbal instructions to create or build something. And what we have to do as an employee is take those written or verbal instructions and figure out how to mathematically make expressions or equations out of them or use them in formulas to then create or build what we've been asked to do. So in order to do that, we have to know vocabulary. Words that mean something in math, like operation. So, simple example is means equals. So I've started you off with just a few that you should already know. So down here we have sum. We know sum is the answer to an addition problem. Okay, difference means subtraction. Product means multiplication. Okay, quotient, division. Ratio we know is like a fraction, so we're going to have a fraction bar, the ratio of 1 to 3, for example. So in this case, ratio would not be 1 out of 3, but it'd be 1 to 3. There's 1 student to 3 homework assignments. Less than means subtraction, but in the opposite direction. So if I say 5 less than 3, that means I'm taking 5 from the 3. So 3 minus 5. So it's a little different than your difference or minus problem. More than means, again, addition, and total means addition. So now let's look at some verbal phrases. They're not equations, so we're not going to have an equal sign and we're not going to solve them. An equation has an expression on one side of the equals and then one on the other. So, first one says translate, which means to change or convert the sum of 8 and y into an algebraic expression. So, in this one, we're going to take sum and change it to addition. And what are we going to add? We're going to add what comes next, the 8 and the y. So, we generally put them in the order that they're written. So this translates to 8 plus y. Next one, translate 4 less than x. So in this case, we know the x is larger because we have 4 less than that. So we know less than means subtraction, but from what I just said in the vocabulary, we know this one has to be turned around. It's not 4 minus x, although that's what we want to do. Okay? We know it's 4 from the x. So that's when that's a special case. More practice, you'll learn that. Okay, translate x multiplied by 13 into an algebraic expression. So we have our x, and we're going to multiply by 13. Now we know from our algebra work that that's not how we would write it. We know that we would take the number and use it as a coefficient in front of the variable. That's the normal way to write that expression. Okay, next one, translate the quotient of x and 3 into an algebraic expression. We know quotient means division. Now, subtraction and division are not commutative. That means that you can't switch them around. 3 plus 5 is the same as 5 plus 3. 7 times 8 is the same as 8 times 7. So addition and multiplication are commutative. It doesn't matter which direction you go. But subtraction and division aren't. So the way that it's written in the problem, with x being first and 3 being second, means my x comes first in my expression and the 3 comes second. So it's x divided by 3, and of course we can write it like a fraction. The last one on this page, translate the difference of 5 and y into an algebraic expression. So we know difference means subtraction, and like I just said, subtraction is not commutative. So the way it's written in the expression, the verbal expression, is how I have to write it in the algebraic expression. So the 5 has to come first and the y has to come second. So that translates to 5 minus y. Fairly simple. Okay, let's go to the next page. So try another one. These are just a little bit more complex. So translate the ratio of 9 more than x to x. So here we have a couple different expressions that we have to convert. So we know ratio means it's going to be a division to begin with, or a fraction bar. The ratio of 9 more than x to x. So 2 would be our fraction bar. 9 more than x, we know more than means addition. So what are we going to add? Well, it says 9 more than the x. So we're going to add 9 to the x, and then that's to the x on the bottom. Now, if we had written 9 plus x to x this way, that would have been fine. Either one would be correct. Next one. Translate 9 less than the total of a number in 2. So we know from the beginning we're going to take 9 less than something. What's the something? The something is this total of a number in 2. So total means we're going to add, and what are we going to add? We're going to add a number, and since we don't know what it is, that's our variable. And what are we adding to it? 2. Now we're going to take 9 less than that. Now the problem with this particular expression is I need to recognize that I'm taking 9 less than something that hasn't been done. So that total of a number in 2 means that I should put parentheses around here because I have to do that first before I subtract 9, even though the way it's written here would have been correct anyway. But sometimes we have to understand where to put parentheses. So that translates to, for me, x plus 2 minus 9. Okay? And then they just simplified it further. Okay, next one. Here are some wordy examples. The length of a football field is 30 yards more than its width. So here I have a football field. Okay? The length is 30 yards more than its width. Express the length of the field in terms of its width, w. So they're telling us what the width is, w. Okay, right there. Okay, well in this case, what they're saying is the width is right here. All right? Because we know it's going to be longer this way. So, the length is 30 yards more than that. So we know more than means addition. So we're going to take 30 and add it to the width, which we already know is w. So we're going to do 30 plus w. And that's fine to write it like that. Or we can write it w plus 30. Remember, addition is commutative, so we can write it either way. So now if I wanted to find the area of this, I know that I could multiply these two things together, so I can use it further. All right, so we have another one. 20 gallons of crude oil were poured into 2 containers of different sizes. Express the amount of crude oil poured into the smaller container in terms of the amount G poured into the larger container. So that first it sounds, very wordy, I guess what they said, but it's not that hard when you break it down. So we know 20 gallons is the number 20. It's poured into 2 containers. So here I have my 2 containers, and one's bigger than the other. Express the amount of crude oil poured into the smaller container in terms of the amount G poured into the larger one. So here's my oil going in. Okay, we know that that's G because it says right here, the amount G poured into the larger one. Well, at some point I stopped pouring it in there. So how much would be left here? Well, we only have 20 gallons total, don't we? So if this big, huge container right here is my 20 gallons, and I'm pouring G into this one, what would be left with that? Well, we know kind of pouring is a subtraction problem. So I'm taking my 20 original gallons, and I'm pouring G into here. So 20 minus what I poured into the large one would leave me what's in the smaller one. And there we go. Now, this takes practice. You have to do a lot of these verbal or written expressions or sentences later for equations to get used to changing the back and forth. So that's why practice is important. And so we'll do more of those tomorrow.